Hi everyone, Dave Daniels from Colossal Fossils in Wausau, Wisconsin, and today's chat is going to be about the Australopithecines, which are a group of upright walking bipedal primates, closely related to modern humans. We're going to go over a few different skulls here and other assorted items that I have in our collection. We've got about 6 skulls that we'll talk about today. And we're going to cover the Australopithecines and why they're unique. A few weeks ago, we had a discussion with some people, and the question was, how do we know that they were walking upright? Well, biggest clue right there is this hole in the bottom of the skull. It's called the foramen magnum. That's where the spinal cord meets up with the brain. Now, chimpanzees and other great apes, if we look at their foramen magnum, here's the skull from a male chimpanzee. Their foramen magnum is here, which means that the spinal cord was coming out at an angle. And if you watch the nerdy documentaries that I like to watch, you'll notice that chimpanzees don't often walk around on 2 legs. They're usually knuckle walking on all 4s. Now with the Australopithecines, however, that's a different story. Their foramen magnum is directly on the bottom. So their spinal cord is coming straight down, just like modern humans and other species in that Homo genus, like Neanderthals and Homo erectus, and the list goes on. So to begin with, Australopithecines first appeared in the fossil record about 4 million years ago and kind of petered out around 2 million years ago. There is another genus called Paranthropus, which scientists originally threw in with the Australopithecines, but due to some anatomical differences, they kind of made them into their own genus. Those ones are actually much younger. They are anywhere from 1 to 2 million years old. First examples that we have right here. We'll do Paranthropus boisei. This first one is about 2.3 to 1.2 million years old. The species itself. So Paranthropus boisei, 2.3 to 1.2 million years old. This individual here is about 1.7 million years old. And you'll notice they've got some crazy wide cheekbones, okay? That zygomatic arch made room for some huge chewing muscles. Now, Paranthropus, bad example. Oh, let's look at this one. Their cheek teeth, their molars, were sometimes 4 times larger than our molars today. So these animals, they got these great big molars. They've got these great big muscles. They have a sagittal crest running along the top of their skull. This was an attachment point for those chewing muscles, okay? These things were eating a tough, fibrous diet, okay? A lot of plants. Australopithecines are not like that, and we'll get into that a little bit. So, back to this one. As we said, he's got the big cheekbones, big teeth, the sagittal crest right there. He's probably male based on what a lot of people are guessing here. The brain case is about 510 cubic centimeters. How does that compare to modern humans? Well, Homo sapiens have an average brain case of about 1,400 cubic centimeters. So our brains are almost 3 times the size of this one right here. So our next Paranthropus boisei, we'll just set that over there, is this one right here. And this is kind of a sculpture that was based off of some original photographs and whatnot. So an artist rendering, if you will. The original is known as OH5, but it's got a really cool nickname. It's the Nutcracker Man. Again, that's because of those giant back teeth there. This was discovered by none other than Mary Leakey herself. Incredible woman. If you haven't read about her, I highly recommend it. She's got a fascinating story. So again, Mary Leakey discovered this at Olduvai Gorge. Giant temporalis muscles. Now your temporalis muscle, if you put your fingers on your temples right here and clench your jaws, you can feel them wiggle around, tighten up a little bit. These animals, their temporalis muscles were approximately 4 times the size of ours. So again, very strong bite force to process those tough fibrous foods. Now another one, this is another species in the Paranthropus genus. This is Paranthropus robustus. They were anywhere from 1.8 to 1.2 million years old from South Africa. I should say the other ones, Paranthropus boisei, are from Eastern Africa. So this one was found in a cave, and it was blasted apart by explosives, and somehow the skull managed to survive. Most likely this is an adult female. We're not 100% sure. Those things seem to change year to year based on who's researching these skulls. So that kind of leads us into the Australopithecines, which are these skulls that I have right here in front of me. Okay, they're a little bit older than Paranthropus. Okay, they had a common ancestor. Big difference that, or biggest difference why Paranthropus kind of went off into its own genus is because Australopithecines don't have the sagittal crest. Okay, their cheekbones aren't as wide. Their molars weren't as large. Okay, there were enough subtle variations and differences between the two groups of animals that they said, nope, they're different. So we know of today 3 different species of Australopithecines. There's Anamensis, which were around from 4.2 to 3.8 million years ago. There's Afarensis, 3.85 to 2.95 million years ago. And then there's Africanus. This is the newest one, okay? They were 3.3 to about 2.1 million years ago, okay? First ones, Australopithecus anamensis. Again, these are the oldest ones. Cool things about these. We know they were walking upright, okay? Africa at this time became very dry. They kind of had split off from their, common ancestor with the chimpanzee. These ones were stuck out in the open, dry savannas, very large distances from tree to tree. So they had to make that distance up quickly to avoid getting eaten by predators. So over time, they gradually developed the ability to walk upright. Now, their ankles were made for bipedal walking, but their wrist bones and their hand bones were very well adapted to climbing up in trees. So these things are probably going from tree to tree during the day for food, and then up at nighttime, they'd climb up into the trees, again, to avoid getting eaten. Looking at the hand bones, this is a modern primate, I think orangutan. If you look at their hand bones, they're nice and curved, okay? Early Australopithecines had the same thing, okay? You can see those hand and finger bones were curved. This was for grabbing onto tree branches, okay? Our hand bones aren't quite that curved. Ours are a little bit straighter. Now, I don't have a skull from Anamensis, but I have 2 partial bits and pieces here. This is the maxilla, so your top teeth, and this is the mandible, or the jaw, the bottom teeth, okay? These are from 2 different individuals, okay? And these date to about 3.9 to 4.2 million years old. I believe they were found in the same area. And they also had some pretty large cheek teeth compared to the younger species that we'll get into, okay? Now, going into our next species, Australopithecus afarensis. This is probably the most famous one, okay? You may have heard of Lucy. She was an individual. I don't have a skull from her. I do have a reconstructed jaw from Lucy, and her cheek teeth are just a little bit smaller than Anamensis there. You see that difference? It's slight, but it's there, okay? Some recent discoveries indicate that Lucy probably died when she fell out of a tree. Pretty high distance too. They found some broken fractured bones, and that did not heal, so they think she died upon impact. This is a reconstruction of an afarensis skull. As you can see, brain case is getting a little bit more rounded, compared to something like, that. Lacks the sagittal crest. Brains were getting a little bit bigger. And between these 3 species, we noticed that their brain cases are getting larger. Older species were eating more plants. The younger species started incorporating more meat and protein into their diets. And when you add extra meat into your diet, your brain has the ability to get a little bit bigger, okay? Better nutrition, larger brains, better problem solving. In fact, there is some newer evidence that Australopithecines were creating stone tools, which is fascinating, okay? We think of these as apes, but they were more than apes. They were, on their way to becoming human. Turning this to the side, we've got a prognathic face where, you know, that the face sticks out a little bit. Humans aren't quite as severe. A nice brow ridge right there. Nice rounded dome, which is very, very nice. Again, Lucy's the most famous one. There we go. Now we get into the last species here. This is Australopithecus Africanus. Again, 3.3 to 2.1 million years old. I have two specimens here. This is a partial one, but it's neat because you can see into the brain case there, okay? And again, compared to the older species, head was a little bit more rounded, brain was a little bit bigger, the cheek teeth were a little bit smaller. So this is Africanus, okay? These were both discovered in 1947 by Robert Broom and his buddy John Robinson, okay? I think this one is a female. This one has an interesting story. It was found in some very dense rock, and they were having trouble getting it out. So Robert Broom decided to use pickaxes and dynamite and blew the skull into smithereens. It was a very intact skull. Unfortunately, after he decided to use dynamite, that wasn't the case anymore. They did find most of the parts and pieces, save for a few scraps here and there, which is unfortunate, but still, this is the most complete Africanus skull known to date. Its nickname is Mrs. PLES, P-L-E-S, and it was assumed for a long time that this was a female. Today, we're not quite sure. Again, depending on who you talk to, some are saying it's male, some are saying it's female, some are saying it's juvenile. We just don't know yet, okay? Not enough out there. Cranial capacity is 485 cubic centimeters, slightly smaller than Paranthropus, okay? But we do believe that we are more closely related to these guys just because of those skeletal features. And again, this one could be young. Maybe its brain got a little bit bigger, all right? So cranial capacity of 485 cubic centimeters. And that about does it for our talk on Australopithecines today. If you have any questions, feel free to drop them into the comments section. I'd be happy to answer them to the best of my ability. Cool thing is, with this science, anthropology, information is changing constantly, which is good. That means we're learning new things. Keep an eye on our YouTube channel. We'll be loading up more videos as time progresses, especially with this COVID-19 outbreak. We've got a lot of extra time on our hands, so we'll be talking about Neanderthals before too long. Maybe you could do a star show as well. So until then, I'm Dave from Colossal Fossils. Adios.